Jan 2009, Core 3 paper, question 6, part A. You're asked to find the stationary points of this curve. To do this, we're going to obviously have to differentiate this. It's going to be done by the product rule. There's two functions, e to the 2x times this quadratic. So we'll say u equals e to the 2x, v equals x squared minus 4x minus 2, u dash equals 2e to the 2x, v dash equals 2x minus 4. Product rule is first differentiate second, plus second differentiates it first, so that times that, plus that times that. So dy dx equals e to the 2x times 2x minus 4 plus 2e to the 2x times x squared minus 4x minus 2. We're asked to find the x values of the stationary points, so we need to factorise this and set it to be equal 0. So first of all, let's factorise it. We've got e to the 2x in both terms, so we've got e to the 2x into 2x minus 4 plus, note the 2 there, 2x squared minus 8x minus 4. Factor of 2 will come out of all of this, so it equals 2e to the 2x. Combining my terms, I'm going to have 1x squared, I'm going to have minus 3x minus 8 divided by 2 minus 4. Expecting this quadratic to factorise, and it does, 2e to the 2x brackets x, 1 minus 4, so I have minus 4 times plus 1. Check-in gives me plus 1x minus 4x to minus 3x. Got to find the x values of the stationary points, so either this is 0, this is 0, this is 0. E to the 2x is never 0. X plus 1, when x plus 1 is, to make x plus 1 0, we need x equals minus 1. So x equals minus 1, or x equals 4, my two solutions. Part B, find the second derivative. So d2y dx squared equals the derivative of on my dy dx term. So make sure I go back to my original dy dx here, and I'm just going to do this in my head by saying the first term, which is 2e to the 2x, times derivative of the second term, which is 2x minus 3, plus the second term, x squared minus 3x minus 4, times derivative of the first, which is 4e to the 2x. It just asks to find d2y dx. I could factorise this down, but I'm not going to risk it because there's no purpose, no need for me to do that at this point. So I'll move on to the next part. B part 2. Determine the nature of each of the stationary points. To find the nature, I've got to put in my x values into d2y dx squared, see whether it's positive or negative. So x equals minus 1. d2y dx squared would equal 2e to the minus 2 times minus 5. If I put minus 1 in here, this will come to 0, so plus 0. So I've got minus 10 lots of e to the minus 2, or e to the minus 2 is a small positive number, times a negative number gives me negative. So it equals negative, therefore maximum at x equals minus 1. At x equals 4, d2y dx squared equals, putting 4 into here, so I'm going to get 2e to the 8 times by 5. Again, if I put 4 into here, it's going to evaluate to 0, so plus 0. So I've got 10e to the 8, which is a positive number, equals positive. Therefore, minimum